In this video, we're going to discuss law of sine. Law of sine is one of the laws that we can apply to non-right triangles. So oftentimes, this is also known as non-right triangle trigonometry. So first, we're going to see how we can derive law of sine. It's not just a random formula or random equation. This is actually coming from observing any triangle that is not a right triangle. So let's look at number one. Start from number one. By using a straight line, construct two right triangles within the given triangle. So it would be helpful if you actually follow along as I do this one. So we're going step by step. That's the first step. Draw by using a straight line. So we're going to label, or we're going to draw a straight line to make a two right triangle. How can we achieve that? From here, I'm going to drop a straight line so that now I form a right angle right here. So now I have two right triangles. And we're going to label this line as H. So we're going to label this length H. And as you can see, the, the length for each is already labeled as A, B, and C. And we also have angle C, angle A, angle B. Okay, so then second step, we're going to express sine of A and sine of B. So for sine of A, we have to look at this right triangle right here. So for this one, sine of A, which is this angle, sine of A, is H over B. We can think as H is the vertical length, B as the radius length, or we can also think as a right triangle trigonometry where is opposite over hypotenuse. So we have H over B. Okay, so let's keep that. And then we're going to find sine of B. So sine of B, we have to use this right triangle right here, this one. So we have to use this angle B. So let's use this angle B. Sine of B, angle B, will be H over A. H over A. Again, all we're doing is just making observations and finding trig function sine of two angles from a given triangle. So it can be from any triangle that is not right triangle. Okay. So fourth step, express H in terms of sine of A. So make sure you use red color. This one I'm going to express as H. That means I'm solving for H. I want to isolate the variable H by itself. So I have sine of A equals H over B. I want to isolate H by multiplying B both sides. If I multiply B both sides, then I get B times sine of A equals H. Or we can just say H equals sine of angle A. So we have this so far. Similarly, let me bring up here. Similarly, we're going to find sine of B, H in terms of sine of B. We know that sine of angle B from right here is H over A. Multiply A both sides, then I get H equals sine, oops, sorry. Let's write A first. A times sine of B. And I just realized I did not write B on the top, so this one, I forgot to type B here, write B here. So H equals B times sine A, H equals A times sine B. So what does this tell us? H can be expressed as B times sine A, or H can be expressed as A times sine B. And what is H? H is just this segment, this length right here. This length can be expressed in two different ways, which means that H is same thing as B times sine of angle A which is same as A times sine of angle B. Okay. So our last step to come to the conclusion of the law of sine, what does this tell us? Let's express this step from 6 without using h. So essentially this is telling us just write these two, and we're going to simplify furthermore. So we have so far concluded b times sine of angle A equals A times sine of B. And here what I'm going to do is I'm going to divide by B both sides. I'm going to divide by B both sides so that we have sine A equals A times sine B over angle B. And then I'm also going to divide by A both sides. So then A will come right here. And this A will cancel out. Let me write that right here. I get sine of A over length A equals sine of B equals length B. So this is a portion of a law of sine. Okay? But let's first interpret this result. So I'm actually going to write what we just discovered again right here. We just found out, we just deduced that sine of angle A over length A equals sine of angle B over length B. Let me emphasize here, A, B, and also C, this is right here, C are angles. This is very important, angle measures. So what does this is saying? What does this tell us? This is saying that sine of angle A, this angle, sine of this angle A over this the length facing the angle A. So length angle A is facing this length, right? So we conveniently label it as A, but in general we can think it's the sine of this angle over the length that is facing that angle, the length that facing that angle is equal to sine of this angle divided by the length that facing this angle, which is this. So that's what this is telling us. That's the law of sine. And this works for any triangle. And it actually turns out we can do this process what we just did one more time by drawing another right triangle. Okay, we can also do this. We can label this as H, and we go with the same process again. Then we'll conclude that angle C over length C, sine of, let me write it here, sine of angle C over facing length C is also equal to these two quantities. So this right here is law of sine. This is the law of sine. And you need to remember this, and the best way to remember this is that sine of that angle facing the length equals to sine of this angle over this length, facing length, and also equals to sine of this angle facing length. So this is always true for actually any triangle, but it's particularly useful for non-right triangles. Okay. So let's look at some example problems. Okay. Here's law of sine, example problems. So essentially this can be helpful to find a certain length or even certain angles depending on the situation. Okay. So here says, bring it down a little more. Find the altitude of the aircraft in the problem introduced in the beginning of the section shown in the figure. Round the altitude to the nearest tenth of a mile. But for us, just writing as expression is good enough since we're not using calculator. But I'll still show you the calculated results just so we can relate in the context of the problem. But the point of this problem or this section is being able to apply law of sine. Okay. So here we have a non-right triangle. But just like we did before, we imagine there's a right triangle by imagining a vertical line right here. So this forms a two right triangle, right? So here we have to make sure we know the which length are we looking for. Okay, what is the length are we looking for? So the length we're looking for is the altitude, which is the h value. Let's label this length as h. We want to find this length right here, h. And only length we know is 20 miles. And we don't know this one nor this one. And we also know these two angles. But once we know these two angles, we can also find this angle, right? Because adding three angles, 15-degree plus 35-degree plus this angle, let's call it theta for now, theta must give us 180 degree. So theta is then 180 minus 15 degree minus 35 degree, which gives us 130 degree. So we know this angle right here is 130 degree. So we know all three angles now. Once we know the three angles, now we can use the law of sine to find the other length because we know the ratio. Okay? So, how do we find this? First, we can definitely use this right here, right? Let me point it out here. Sine of this angle over 20 miles. So, sine of 130 angle, 130 degree, which is actually a value. We can find this. This is a known value in terms of calculator, right? 130 degree. So this is a number that will give us actually a distance. This over 20 miles will equal to, let's do this. Let's find A first, and I'll explain why we need to know A. So we can find A by setting up this angle, sine of 35, over A. Okay. So that's one way we can write the law of sine. And let's find A. When I say find A, all we do is just solving for A. So I'm going to multiply A both sides. I get A times sine 130 degree over 20 equals sine 35 degree. I want to solve for A. That means I can just multiply the reciprocal of this. Oops, sorry, I didn't mean to erase. Multiply reciprocal of this to here. Then I get A equals sine 35 times length 20 over sine of 130 degree. So this is length A. Okay, and this is actually a number. Okay, we could find this number, but we can just leave it like this. This is good enough. Okay. So we know that this length is now this right here. Then how can we find h? Well, in order to find h, now we have to look at this triangle, this right triangle, to find the length h. And of course, if you know this length right here, then we could use Pythagorean theorem. But that's not the case here. So we have to use the law of sine. And law of sine is applied to all triangles, including right triangles. So we can find this by using law of sine again. So in this triangle, we have to do 90 degree, this angle, sine of this angle over A. So let me write that right here. This is the second step of this problem. Sine of 90 degree over length A equals sine of 15, sine of 15 over h. Sine of 15 over h. Okay. And it is helpful. We know what sine of 90 degrees from the unit circle. Right? From unit circle is right here, 90 degrees here. Sine value is 1. Right? This is 0, comma 1. This is the sine value. So if you know the value, it's helpful to write it. So 1 over, what is a? A is this value right here. So it's 1 over that entire thing. 35 degree times 20 over sine 130 degree. 130 degree equals sine of 15 degree over h. So this one's 1 over fraction. I can write reciprocal. So let me read out the whole thing. I have sine of 130 degree over, let me write 20 first, 20 times sine 35 equals sine of 15 degree over h. Again, we're solving for h right here. So I can multiply h both sides. I'm running out of room, maybe zoom in. So h, to solve for h, is, if I multiply h here and h here, this cancels out, right? So then I have h times this thing equals sine 15. But then I can multiply reciprocal of this to isolate h. H will be then sine 15 degree multiplied by 20 times sine 35 degree over sine 130 degree. So this is the final answer. Okay. So we just applied law of sine to find this length h right here. Okay. So I know this. If you're looking at this, oh, how do we don't know this length? But these values right here, these three sine values, are known value. They are already computed in terms of we can always find using calculator. But since we're not using calculator for our course, you can just this is acceptable answers for the exams. Okay. But for homework, they'll ask you to find the around the 10th decimal. That's why we're doing it. But again, this is just one last step, the writing. So for homework, for our purposes, just type this answer in a online calculator, and it'll give you the number. And make sure angle is set to degree already depending on the problem. So if you type this in a calculator, you get about 3.87 miles. So this is the final answer. So this length is about 3.7 miles. Again, I want to make it clear that for exams, for our purposes, this is acceptable. Okay. For homework, it just asks you extra step, type these expressions, and type the number. And type this in a calculator, online calculator. If you just type this in Google, it will do it for you. And this is the numerical answer. So let's look at second example. Let me draw a triangle. Here we have a triangle ABC. And I'm not necessarily drawing in scale in terms of angle because we don't know all the angles. Now let me just draw it. It's messing me up. Let's do something like this. And you can label it any way you want. We can do A, BC. Okay. And it says angle A is 40 degrees. It actually forgot to give angle B also. I'm sorry, angle C. Angle C is 50 degrees. I'm sorry, 60 degrees. 60 degrees. So angle C is also given. I just forgot to type it. 60 degrees. And this make automatically, what is this now? 100, so this is 80 degree. I know again, scale is kind of off. And it tells us that length AB is 10 centimeter. BC is 8 centimeter. Find the length AC. This is the length we want to find. Okay. So it's not a right triangle. So we cannot apply Pythagorean theorem to find the third length. This is where law of sine can be very useful. So let me write the law of sine one more time. Law of sine says that sine angle A corresponding length equals sine angle C corresponding length sine B corresponding length. Okay. But this also means if I flip this fraction, A over sine A, angle A, equals to C over sine angle C is also true. Oops, sorry, the length B right here. So these two are equivalent. So when we say law of sine, you can use either one of them. Okay. So it is derived as this one, but actually oftentimes it might be algebraically a little simpler to use this version right here. But either one works. Okay. So how do you find length x? We have to use law of sine. So what we know the sine of this angle over x is part of law of sine, right? Over x equals, now we can use any of them. We can use sine of 40 or sine of 60. Let's use sine of 60 because we know sine of 60 from the unit circle, right? So sine of 60 over 10 centimeter, 10 centimeter. What is sine of 60? 60 degree is right here, same as pi over 3. It's half and square 3 over 2. So this value is square 3 over 2. Let me write that. Next line. So we have sine of 80 degree over x equals square 3 over 2 over 10. So we can cross multiply. Oh, let's actually simplify this first. We can multiply, we can multiply with the reciprocal, which gives us square 3 over 20. Now here we can cross multiply to solve for x. We have square 3 over x times x, sorry. 20 times sine of 80 degree. X equals 20 times sine of 80 degree over square root of 3. And this is good enough. This is the acceptable answer for us. Okay. But again, the homework will ask you to find a certain decimal place. Just type in a calculator on Google or any online calculator. Make sure angle is set into degree. This will give us, let me type in my calculator. It gives us about 11.37 centimeter. But again, for our purposes, this is good enough for exams, because the whole point of this is being able to apply the law of sine and solve for the unknown variable.